Good morning, students. So today we'll discuss the uh, fourth part of this chapter. So today's topic is data rate limits. So in that uh, in the today's lecture, we discuss how the data rates are uh, uh, limited for sending any data communications. So first of all, in the first part, we discuss in the data rate what is how it depends. So a very important consideration in the data communication is how fast we can send data in a bit per second over a channel. So actually कितने फास्ट हम लोग वो सेंड कर सकते हैं, that is the main concept in the data communications. So these data rates depends on, first one is bandwidth available, second one is level of the signals we are used. Number of level is there more, then bit rate also be more. If bandwidth is more, bit rate also be more. And the quality of the channel means level of the noise. If noise level is more, the quality will be less. So that is the main fundamental thing of sending the data. So in that topic we discuss noiseless channels. One is the Nyquist bit rates, another noisy channel for Shannon capacity, and using this both, mixing of both, how we send the data. What is the concept? Okay, now if we consider the increase the level of the signal, increase the probability of the error occurring. So suppose we have to send more data. So हम लोग को क्या करना है, लेवल उसका ज्यादा करना है. मीन्स दैट मीन्स if we combine more number of levels, we combine more number of data and we can send it. So that means your data rate should be more. But here is the fact is that if data rate is also more, then your error rate, occurring rate also be more. So it, in other words, you can say that it reduces the reliability of the systems. Now question is how. So in the next slide, we discuss the concept of this. So actually, in that Nyquist channel, so uh, according to this formula, I just coming to this formula later in next slide. So in that formula, we might think that the bandwidth is, so this is the formula. The Nyquist formula is that 2b into log base 2, actually 2n is level or consider. So in that formula, it's that if bandwidth is fixed, if you increase this level, the channel bit rate, data rates, you can say that it may be more. So this bit rate of the system increase when the increase of the signal level, that is used this denoted symbol. So this symbol consists of the single bits or n bit. N bit means level is 2 to the power n. As the number of level goes up, the spacing of the between the level between this level is decreased. So obviously, if it is the level is decreased, then the complexity creates more. That increase the probability of the error occurring in the presence of the transmission impairments. So means if we increase levels, means on the beyond the saturations, one point is there, beyond the limitations, then your error also be increase. So that's why we consider some optimum way to send and increase the level, and as well as data also send in the error free way. So that is the Nyquist theorem. In the Nyquist theorem, it is used for the noiseless channel. In that theorem, it defines the theoretical maximum bit rate you can say I just again repeat this line, theoretical maximum bit rate. It's this formula show the what is the maximum bit rate that you can send from a channel. So that gives the upper bound of this bit rate of transmission system by calculating bit rate directly from the number of bits in a symbol, or you can say signal level at the bandwidth of the system. Assume two symbols per cycles means the first terminal. We already uh, seen this in the last class, on the last lecture, that the worst case, this the first harmonic uh, two symbols per cycle is required in the first harmonic session. Mean the worst case means minimum bit rate will be like that. So in the Nyquist theorem state that for the noiseless channel, it is C equal to 2b log base 2 to the power n. Here C is the capacity of the bit per rate bit per seconds, and bandwidth in the hertz, and 2 to the power n is means the number of levels. Okay. So in that level, if we fix the bandwidth, if we increase this level, you can say that the bit rate will be the yes, bit rate will be the more, but somehow it's not a realistic. So now there is a question. So does the Nyquist theorem bit rate agree to the intuitive bit rate described in the baseline transmission? So what is the answer? So see, they must be, actually it is only happen in the two levels for. So we said the baseband transmission, the bit rate is the 2 times of the bandwidth. If we use only the fast termination in the worst case, however, Nyquist formula is more general than what we derive intuitively. So it can be applied for the baseband transmission and modulations. Also, it can be applied when we have two level also. So in the baseband transmission, it will only consider the 2 level only. 2 level if it is, then it may be doubles. By the theorem, we can see that the theorem, if it is by 2, so it is, if it is half, then it will be the minimum bandwidth you can find. So if it is more, then it needs modulations. So this is another problem. Consider the noiseless channel. So bandwidth of 3000 transmission and 2 levels. So easily find out the maximum bit rate here. The bit rate will be 2 into 3000 the bandwidth log base 2, because 2 is 1, so 6000 bps. Next, another problem. Consider same noiseless channel transmission signal, 4 signal level now. With 4 signal level. So for each level we send 2 bits. So how we find out the maximum bit rate? So 2 signal, so we send 2 bits. So 2 into bandwidth is 3000. Level is 4. So 2 to the power 2 is 2. So it is 12,000 bps. So by that we can do some problem. So in the assignment I will give some small numericals like that. So it is another important numericals. You see here, the question is that we need to send 265 kbps over a noiseless channel, a bandwidth of 20 kilohertz. How many signal levels do we need now? We have to find out how many signal levels. So by the Nyquist formula, we see that. So that is the maximum capacities noiseless channel 2 into 2000 kilohertz, and is the L. Now find out the L log base 2. If found, L will be 2 to the 6, which is 98.7 levels. So now the question is, this level is realistic or not? No, it is not realistic. Since the result is not to the power 2, we need either increase the level or reduce the bit rate. If we have 128 levels, bit rate will be 280. If we consider, if we have it to 120, if we put it in this formula, the result will be 280. And if it is 64, there will be 240. So we consider this lowest one, because maximum, if it is considered the maximum, so obviously more than that you cannot send the level. So if it is better performance, you need to send maximum 64 levels and bit rate is 240. That will be the answer. So now for the noisy channel. So in reality we cannot have noiseless channel. So the channel is always noisy. Real life में हम लोगों का सभी noisy channel होता है. So in 1944 Claude Shannon introduced a formula. It's called Shannon capacity to determine theoretical highest data rates. I am repeating, this formula is used for theoretical highest data rate for the noisy channel. So the formula is C equal to B log base to 1 plus SNR. So SNR is a signal to noise ratio that we already discussed in the last class. So now consider an extremely noisy channel in which the value of the signal noise ratio is almost 0. Now we can say that here in that formula, the bandwidth, B is for bandwidth, SNR is the signal to noise ratio, C is the capacity of the channel per in the bit per second. So here you just noted that the Shannon formula, there is no indication for the signal level, which means that there is no matter how many levels we have, and we cannot achieve a data rate higher than this capacity of the channel. So it is the maximum capacity of the channel. So in other words, we can say that the formula defines the characteristics of the channel, not the method of the transmission. So this is very important line. It is the characteristics of the channel, not the method of the transmission. Here, that is the said. So now this is the formula. To consider this external noise channel, if SNR external noise channel means SNR will be 0. So you know noise is so strong, so signal is faint. So here C will be B log base to 1 plus SNR. So 1 plus 0. So it will be 0. That means the capacity of channel is 0 regardless of bandwidth. So you have a bandwidth here, but we can say that this capacity is channel is 0. Now in the other order we cannot receive any data through this channel. So next is, so we can calculate the theoretical highest bit rate regarding telephone lines. That if it is bandwidth is 3000, signal ratio is this. Now I find out this capacity. This means this is the highest capacity, 34.0. If we want to send the better or faster data, then we have to either increase the bandwidth of the lines or improve the SNR ratio. Now a signal is often given the decibel. So now we have to find out the relation between decibel, SNR dB and SNR. Sometimes assume that SNR dB is 36. The channel bandwidth is 2 megahertz. So now SNR dB equal to 10. This is the formula 10 log 10 SNR. So this is the formula. By this we will find out the value of this. So if sometimes SNR dB gives, then you find out the SNR also. Then after you put it in the formula. Okay. So next is normally one thing you should remember, if SNR is very high, you can assume that SNR plus 1 is almost same to SNR. Sometimes we use another formula, C equal to B SNR dB by 3. By that we can put the formula and value also. By that you sometimes if it is SNR dB given, then using this formula you can find out the channel capacity. Okay. Now another problem is that we have channel with 1 megahertz bandwidth. SNR for channel is 63. Now same thing. The first we have to Shannon formula to find the upper limit here. C equal to B log base to 1 plus SNR. By that we find out the upper limit. Now the Shannon formula gives the upper limit. So the better performance we have to choose less than that, means power of 2. If it is 4 Mbps, okay. So for this, if not this value is not assuming, this value assume that the level should be in the decimal value. It not should be in a fractional value. So by that we have to choose in lower value. जैसे level आपका fraction में नहीं आए. So level should be in a power of 2 to the power n. So by that if it is 4 Mbps, then your level will be the 4. That's why it's the best better performance के लिए हम लोग L4 ले सकते हैं in that case. So next is, so these are the problems that we have to discuss. So here we can say that in that mix, first we find out the upper limit, then after by the Shannon capacity gives us the upper limits. Nyquist formula tells us how many signal level we need. So by that, here in the previous example, we find first by the Shannon capacity, find out the upper limit, then use the Nyquist formula and find out the actual. So by mixing up this, we can find out the best data rate in the signal. So in that part, up to this we just conclude here. Okay, good day.